So this is our straw shooting lab by Inbal, Shlesinger, Mark-Phillip, Buesa, John Darroch, and David Bunce, who is not here. So we had a constant power of 2, and we measured different degrees, and you can see that the distance that was the furthest was 30 degrees, which was 330 centimeters, and the distance that was the least was 30 centimeters for 80 degrees. So here's a graph. You can see that 30 degrees was the most and 80 was the least, and how it curves like that. Then we had a constant angle of 40 degrees, and we tested different powers. And you can see that for the first power it didn't go at all. The most for this was power of 7, 1,260 centimeters, and the least was 0 for 1. And here's a graph of that. You can see it goes in the general direction of going greater.
Alright, so the possible sources of error. First one is the fact that we changed straws in between measurements, in between data sets. We had 3 different straws in total between the first data set and then also the second one. This can cause a problem just based on the way if air can get out of the straw, if there's an error with the straw. Second one is approximation of where the straw lands. This played a key factor in the angles that were really low or really high, just because the straw bounces quite a bit, especially when it's really low. And then the third one is testing only certain angles. Our conclusion will only be based on the angles that we were able to test, like 30 and 35, 40 degrees. We wouldn't be able to test 31, 32, all those intervals in between. So our conclusion is on the approximation of the best data.
Next, we tested 3 different angles. The first was 45 degrees. We used the 3 highest powers available. And it shows that the greatest power for 45 degrees was 6, resulting in 1,263 centimeters, which was our average. Next was 35 degrees. And for this one, the power of 7 was the greatest. For 25 degrees, the power of 6 was greater. We did the top 2 powers, as anything less would result in very inaccurate data.
Other factors that we could change. First one's the type of straw. We would want sturdier design, that way there's less room for error. The second one is error wind factor. Because the mass of the straw is so little, it's strongly affected by the wind or air, which we saw during our testing days was very strong, and plays a key factor into where it lands, rather than going straight, it goes sideways. And on that note, also the method of measuring. If it went sideways or a little bit diagonal, we just kind of approximated where that would land, which caused a bit of error as well. In conclusion, we decided that the best power was a power of 6. Anything stronger or bigger than that would offset that, and we decided the best degrees is around 30 degrees, but the difference between that and the next closest is very low. So there's a lot of degree of ambiguity around that.